Hi, I am Adil and today we are going to talk about LDI and an instruction. For this purpose, we are going to develop a program for Delta DVP-EX2 in WPLSoft. So what is LDI and an instruction? In the previous video, we talked about LD instruction. LDI is totally opposite to that LD instruction. LDI is the abbreviation of logic contact. It is a normally closed contact, which means it will allow to pass electric current until or unless we don't press it to turn off. Similarly, it will not turn off to stop the passage of current until or unless we don't press the switch to turn on. From normally closed contact, we can also say that at initial state of the system, the switch will pass electric current even if electric supply is given to the switch. We can say that it is a switch which is totally opposite to the normally closed switch. We can also explain it as if we turn on this switch, then we get no output. But if we turn off the switch, then we will get the output. It is an input to PLC which can be from mechanical switches, sensors, or triggers or activation devices. From mechanical switches, we can take examples of push button. From sensor, we can take example of heat sensor, range sensor, smoke sensor, pressure sensor and many more. The variable used for these inputs are x0, x1, x2 and so on. Similarly, if we talk about AND instruction, then this statement is used at the end of program. Just like in previous video, we don't place AND instruction in the program and compile it, and then compiler automatically write AND statement to show that there is no error in the newly created program. Program created for the PLC run in loop, which means when the running state or in the running state of the program, the processor executes the AND statement of the program. Then after that, it goes to the first statement of the program and then start executing the commands from the initial part of the program. So AND statement is useful to run programs in a loop, or compiler place it in the end of program to run the program in loop. So I hope you get the idea of LDI and AND instruction. To master these instructions, let's practice some examples. In our first example, we are going to make a simple program with the combination of LD, LDI and out instruction. In this program, we have two switches which are X0 and X1 along with one output which is denoted by Y0. Now what this program do is that if we press the X0 switch to on, then our output Y0 will turn on, and in that on state, if we turn X1 on, then our output Y0 will turn off. In all other cases, Y0 will remain off. So let's have a look on this example. So here I have my WPLSoft 2.46. Let's open it. Click open. Now create a new program which is Ctrl+N. I'm gonna name it as LDI switch and select the PLC type, which is in my case it is EX2, so I'm gonna select EX2 and click OK. Now maximize the ladder diagram mode. Now here our first switch goes. Our first switch is X0 and the second switch is X1. Now we're gonna set the first switch to as LD instruction, which is a normally open switch, and we're gonna put X1 as normally closed switch. So by the instruction we write it as double click LD X0. Now to put LDI here, we're gonna place instruction as LDI X1, which is like this, LDI X1, and hit enter. Now there is another way to put X1 in here. which I'm gonna show you. You can see here is F2 which says normally closed, which is contact P. Click on it, and here you can see X0, and we wanna place here X1, and also here its range is given from X0 to X377. I'm gonna comment it as second switch and click OK. Now at the end of this instruction, this complete set of instruction, I'm gonna place a output device which is Y0. So here I write out Y0, and at the end of the program we're gonna place AND instruction, which is simple as that, E N D, and hit enter. Now you can see AND instruction or AND statement is placed here, which means that our program has been ended, so processor can execute from the initial. So simulate this. Oh sorry, we're gonna compile it first. Forgot that. And then we get into simulator mode and get into online mode. Click yes, and then run the program. Now you can see the program is at initial state, and our X1 is on because it is normally on or normally closed switch, which means it will allow to pass electricity even if it is not pressed. So if I turn the X on, now you can see that our Y0, which is our output device, it is turned on. But if I set on X1, then you can see our output device, which is Y0, it is now turned off. The reason is that X1 was a normally closed switch. When we press the X1, it becomes open, which means electricity is not going to pass through this switch. So path has been cut, and now Y0 is off. And if I turn off, then you can see Y0 is turned back on. So here is how this normally closed works, and you can see our program is running in the loop. This here is run, and this end statement is telling the compiler that it will go to the initial step of the program where it is started. So I turn off the simulation, get out of the online mode, and turn off the simulator. In our second example, we are going to make a conditional program with switches and outputs. In this program, we have 4 outputs and 3 switches. The 3 switches are X0, X1 and X2, whereas the 4 outputs are Y0, Y1, Y2 and Y3. For this program, we have 4 conditions. The first condition is that if first 2 switches are on, then Y0 will be activated. The second condition is if the first and last switch is on, then Y1 will be activated. According to the third condition, if last 2 switches are on, then Y2 will be activated. And the last condition is that if all the switches are off, then Y3 will be activated. I have already created this program, so let's have a look on this. So here is our example, which is named as switching. First I open it. Now WPLSoft is opening. And you can see here, according to our example, we said that our problem will have 3 switches and it has 4 outputs. Now you can see here our switches, which are inputs, are X0, X1, X2, and our 4 outputs are Y0, Y1, Y2 and Y3. Now according to our first condition of the problem, we said that if X0 and X1 are activated, then Y0 gets activated. Now you see here that we have used X0 and X1 are normally open contacts, but X2 is normally closed contact, which means we can revise our first condition as if first and second switches, which are X0 and X1, are on and X2 is off, then our first output, which is Y0, will get activated. Now you can see here X2 is used as normally closed contact, which means At the initial state of the program, it will allow to pass electricity through it to get y1 on. So x1 and x0 are normally open contacts, which means they are not pressed already. When we press them, then they will pass electric current to activate our y0. But x2 should remain off to complete or make the statement true. Similarly, if our first switch and last switch is on, then our second output, which is y1, should get activated. But at the same time, for this condition, x1 should remain off. Now, according to our third condition, we have said that our last two switches, which are x1 and x2, is on. Then our third output, which is y2, will get activated. But at the same time, our first switch, which is x0, remain off. Now, according to our last condition, we have said that if all the switches, I mean x0, x1 and x2 are off, then our last output, which is y3, should get activated. Now, to test this program, we first gonna compile it and then turn on the simulator and turn on online mode, click yes, and run the program. Yes. Now you can see that at the initial state of the system, our three switches, which are x0, x1 and x2, are off. That is why our fourth output, which is y3, is activated. You can see x0, x1 and x2 are off to activate y3. Now if I turn x0 on and x1 on, which is according to our first condition, that first two switches should be on to activate y0. So when x0 and x1 are on, our y0 will on. But at the same time, x2 is off. Now in normally closed contacts, their working are totally opposite to normally open contacts. Which means if I actually turn it on, then the flow of electricity is cut, which is opposite to the open contact, which when I press the button, then it will allow to pass electricity through it. So I turn it off again. So you can see our y0 is now activated. Now I turn off the x0 and turn off the x1. So according to our second condition, which was if first and last switch, which are x0 and x2 are on, then our second output, which is y1, will be activated. Now if I turn x0 on and x2 on, then you can see that our second output, which is y1, is now activated, whereas our x1 switch remains off. Now I turn off the x0 and turn off the x2, and now according to our third condition, which was that if last two switches are off, then our third output, which is y2, will get activated. But at the same time, x0 should be off. So if I turn on the x1 and turn on the x2, now you can see that our third output, which is y2, is now activated. And at the same time, our first switch, which is x0, is off. So if I turn off this one and also turn off the x2, now you can see our last condition is now true. So it will activate our third output y3, which means if our three switches are off, then our fourth output, which is y3, will be activated. Now I turn off the simulation and turn off the online mode and get out of the simulator. Now let's talk about some real world problems. For example, we have a garage door. We want to control the door by three switches attached with the door. The first switch is for moving the door upwards. The second switch is for stopping the door at a specific position or in case of emergency. The third switch is for moving the door in downwards direction. In this setup, we have two outputs. The output y0 indicates that garage door is moving up and Y1 indicates that garage door is moving down. In addition to this setup, we attach two sensors at the top and bottom of the door. Now what our program do is that when we press the up button, the door starting to move in upward direction and stop going up until the sensor attached on the upper side of the door gets activated. Now if I press the down button, then the door starting to move in downwards direction and stop going down until the sensor attached on the bottom side of the door gets activated. In this state of moving, when I press the stop button, the door stop at the spot, and when I release the stop button, then door began to move upwards or downwards according to the button I have pressed before. Now what these sensors do is that when door is fully opened or closed, they disconnect the signal to motor or shut off the motor to avoid any damage. So let's have a look on the program itself. So here I have already created my example, which is named as garage door. First of all, I open it. Now WPL soft is opening. And now our example is now loaded. Now you can see that we have said in our statement that we have three buttons, which is for moving up the door, moving down the door, and the middle one was the stopping the door. You can see here X0 is our up button, X2 is our down button, X4 is our stop button, X1 is our door sensor which is attached on the top of the door, and X3 is our bottom sensor which is attached at the bottom of the door, and our output Y0 which is for indicates that door is moving up, and our second output which is Y1 indicates that door is moving down. So first of all we will compile it and turn on the simulator mode, and now get into online mode, click yes, and now run the program. Now if I press the up button, then the door should move in upward direction, which is indicated by Y0 here. Now you can see door moving up indication. So if I turn the X1 on, you can see our Y0 is now moving up, which means door is now moving up. And if now door is fully opened, and let's say our top sensor which is attached on the top of the door is now activated, so it turns off the door to move up, which means it will not pass electric current to let the door move in upward direction. So if I turn off the X0, which means our operation is now completed. Now when I press the door down button, or when I press the down button, the door should be moving in downward direction. So if I turn on X2, you can see door is now moving down. Now let's imagine that when now door is moving down, at the same time the sensor attached on the top of the door will now deactivated, which means it will be off because it is no more fully opened. So the sensor attached on the top of the door is now deactivated. So now door is moving in downward direction. So when the door is fully closed, then the sensor attached on the bottom of the door is now activated, which here is represented by the X3. So if X3 is now activated, now you can see door stops moving in downward direction. So X2 will also be set off because switch was pressed and now our operation is now completed. So X2 is now off. So at the same time, let's say I again want to move the door in upward direction. So I turn on the X1 you can see our door is now moving up, and at the same time our sensor attached at the bottom of the door is now activated because door is no longer fully closed. So door is now moving up. So X3 is now off. Let's say the door is in the middle position and I want to stop it right there. So X1 is our stop button. So I turn on the stop button at the same time. You can see door is stopped. Now garage door is still in the middle position or whatever the position we desire to set it on. So door is now stopped. But when I release the stop button, you can see door is now moving up because I have programmed already that door is moving up. And then when the upper sensor of the door is activated, which means the door is now fully open, then it will automatically turn off the door to move up, and then X0 will also be off. Now this was the example. I turn off the simulation, get out of the online mode, and turn off the simulator. Now let's talk about another real world problem. In this problem, we have stairs with one light attached on the top. The stairs have two switches. One switch is attached at the ground floor and one switch is attached on the top floor. When we climb the stairs, then we press the ground floor switch to turn the light on. And when we reach at the top floor, then we press the top floor switch to turn the light off. I already have made a program for this, so let's have a look. So here I have already created a program for our problem, which is named as stair light. So first of all, I open it. Now WPLSoft is opening up. And you can see that here we have two switches, which is X0 and X1, and we have an output which is our light, which is attached at the top of the stair. So X0 is denoted for our switch at the ground floor, and X1 is our switch attached on the top floor. So imagine a situation when there is a night time, and if someone wants to climb the stairs and he press the X0 on, which is attached on the ground floor, and light turns on, and then he climbs the stairs and reach at the top floor, and then he presses the switch and that light turns off. So here we have a similar situation. If X0 is on and then Y0 is on. If X1 is then on, then Y0 is on. Y0 is on or off. So how this program works is that if both switches are in the same direction, from same direction, I mean both the switches are on or both the switches are off, then our Y0 will be activated. So let's test the conditions. First of all, I compile the program, turn on the simulator and get into online mode, click yes, and now run the program. Now you can see that the switch attached on the ground floor and switch attached on the top floor are in same direction. I mean they are off. So our Y0 is now. Let's say we have a condition like this. It means the X0 and X1 are not in the same direction. It means one switch is on and the second is off. So when someone climbs the stair, the X0 will be activated, so stair lights gets on, and once someone attached on the top floor, then he will activate X1, which is the switch attached on the top floor, so light becomes off. So this was a simple application. I hope you understand it. So I stop the program, get out of the online mode, and turn off the simulator. So I hope that you get the idea of LDI and N instruction. If you have any problem regarding today's discussed instruction, then please feel free to ask them in the comments below. In the next video, we will talk about latch. The links of today's discussed examples are given in the description below. I hope that you liked today's video. So stay tuned for the next video. Bye bye.